All right, in lesson 1, we talked about simplifying radicals. In this lesson, from objective 4.2, we are going to talk about a different kind of number, a complex number. So let's start with a warm-up question. What numbers would make the following equation true? X squared equals negative 1. What number, when we square it, will give us negative 1? Well, if we try positive 1, squaring positive 1 gives us 1. So that's not going to work. So let's try squaring negative 1. Well, negative 1 squared is also positive 1. So that doesn't work either. So it turns out that the above equation has no real solutions, because squaring any real number will result in a negative answer. So this is where complex numbers come in. It uses the imaginary unit I. I is defined as the square root of negative 1. Another definition that you'll need is I squared equals negative 1. I can be used to write the square root of negative numbers. For example, the square root of negative 3. We can't simplify the square root of 3, but I can pull out an I because I see that negative underneath the square root. So I pull the negative out, make it an I, and leave the square root of 3. Let's do a little more with this. Square root of negative 81. Square root of 81 is 9, and since it's negative, it's going to be 9i. Square root of negative 24. 24 is not a perfect square, so we're going to have to do something else with it. So we're going to go back to what we learned in lesson 1. What perfect square goes into 24? Well, 4 does. So I can rewrite this as 4 times 6. But since 24 is negative, I have to make one of those numbers negative. I always put it with my perfect square. Square root of negative 4 is 2i. And that square root of 6 gets stuck as a radical. I can't simplify the square root of 6 anymore because 6 is not divisible by any perfect square. So that is my final answer. C, 2 times the square root of negative 9. The square root of negative 9 simplifies to 3i. So I have 2 times 3i. 2 times 3i is going to be 6i. All right, let's talk about the definition of a complex number. Complex number written in standard form is a plus bi, where a is the real part and b is the imaginary part. We always write the real part, then the imaginary part when we're writing in a complex number. This next example goes back to what you learned in the last unit with multiplying. The i's act a lot like x's except for in one special situation where I'll show you. The first step is going to look just like what you're used to doing. We're going to distribute this 2i. So 2i times 3 is 6i. 2i times negative I is negative 2i squared. Now, if you look up on your page, I squared equals negative 1. So the big difference between I and any other variable is that we're not going to leave it as I squared. We're going to rewrite it because I squared equals negative 1. Now, multiplying negative 2 by negative 1 just changes the sign. So from now on, we're not going to rewrite it like that. I'll show you the trick that I use. Go back to how we write our imaginary numbers, a plus bi. So we always want to put that real part followed by that imaginary part. So let's take a look at b. I'm going to do this one slightly different. So first we'll start off the same. We're going to distribute negative 4i. Negative 4i times 5 is negative 20i. Negative 4i times negative 7i is positive 28i squared. So what I do when I see that I squared is I know that that equals negative 1, which means that it's going to change the sign of whatever number it's attached to. So I get rid of the I squared and I change the sign. And then remembering that I have to rewrite it so that the real part's first, I flip them around. So the negative 28 is going to go first and the negative 20i is going to go second. Let's look at another one just like that. So we're going to distribute the 4 minus 5i. 4 times 3 is 12. 4 times 2i is 8i. Negative 5i times 3 is negative 15i. And negative 5i times 2i is negative 10i squared. So eventually here we're going to add our like terms, but before we get around to that, I'm going to go ahead and change the sign on this I squared. I'm going to get rid of the I squared and make this a positive. I do that because I squared equals negative 1. So now, since my I squared is gone, I just have 12 and 10, which are both constants, and I can add those and make it 22. I have 8i and negative 15i, which I can add and make negative 7i. No more like terms, and it's in the correct order, so this is going to be my final answer. Okay, let's go on to this last example, example 3. Here we're dividing complex numbers. This is really similar to rationalizing the denominator that we learned in video 4.1 part 2. We can't have an I in the denominator, just like we can't have a radical. When you see an I in the denominator, if it's part of a monomial, meaning there's no plus or minus in the denominator, this is what you're going to do. We're going to multiply on top and bottom by I. So 3 times I is 3i, and 5i times I is 5i squared. Now remember that I squared changes the sign. So I'm going to get rid of that I squared, change the sign. So my answer would be negative 3/5 I. Now why did I move that negative out of the denominator? Typically the notation, with math notation, we don't leave the negative in the denominator. That I has moved up to the numerator, so no longer in the denominator, so we are good to go as far as our simplifying rules. Let's take a look at B. Okay, so I see the I in the denominator. I'm going to get rid of that because we're not allowed to have that. So I'm going to multiply on top and bottom by I. Now on top, I have to make sure that that I gets distributed to both parts. 3 times I is 3i, and 7i times I is 7i squared. On bottom, I have 4i times I, which is 4i squared. Now I'm going to get rid of my I squareds and change the signs. Now, typically, like I said, we don't keep a negative in the denominator. Right now we have negative 4. In order to get rid of that negative in the denominator, I'm going to change all of the signs in the numerator. I'm going to make the top negative 3i plus 7 over positive 4. I changed all of the signs to get that negative out of the denominator. Last question. Once again, I have an I in the denominator that we need to get rid of. So we're going to multiply on top and bottom by I. Distribute that I. 5 times I is 5i. Negative 2i times I is negative 2i squared. And on bottom we have 3i times I, which would be 3i squared. I'm going to get rid of the I squared and change the signs. And then once again, I have a negative in the denominator, so I'm going to change all of the signs. Make positive 5i negative, make positive 2 negative, and make negative 3 positive to get that negative out of the denominator.